Good afternoon, and welcome to today's Roads and Bridges webcast. Our topic is Empowering Work Zone Safety Through Connected Technology, sponsored by the American Traffic Safety Services Association, aka ATSSA. I'm Gavin Jenkins, Senior Managing Editor of Roads and Bridges, and I will be moderating this session. Before we dive into today's presentation, let me explain how you can engage with us during the webinar. If you encounter any technical issues, please type your concern into the Ask a Question, and a member of our team will assist you. We also encourage you to submit your questions throughout the event. We will address as many as possible during the Q&A session after the main presentation, but feel free to send in questions at any time using the Ask a Question box. To refer a colleague to today's webcast, share it on social media, or access event resources, click the icons on the left side rail of your screen. Lastly, please note that today's session is being recorded and will be available on the Roads and Bridges website within the next week. You will receive an email notification on the recording. Once the recording is live. Now it is my pleasure to introduce our speaker. Todd Foster is the Vice President of ITS Engineering for Vermac Incorporated, where he leads the design and deployment of portable ITS systems across North America. Todd has been involved with smart work zones since their inception in 1999. With more than 35 years of experience in transportation planning and engineering, Todd brings a unique blend of technical expertise and field-proven insight. His career covers roadway design, signal system design, a wide variety of traffic studies and ITS applications. Todd's many years of consulting engineering, public service as a traffic engineer, and lengthy service in engineering-related sales has aided his over 16 years helping Vermac shape the smart work zone market and strategies for the future. It's great to have you with us, Todd. And we are excited to learn more about connected technology and how it is empowering work zone safety. So the floor is yours.
All right. Thank you, Gavin. Welcome, everyone, on this summer Thursday. It's always good to see good attendance, and it's tough to come by in the summer. I appreciate everybody's time. As mentioned, we're going to talk about how we can empower more safe work zones by using connected technology. And really a lot of that, I believe, is about increasing driver awareness in these critical work zone areas. As far as the goals today, like I said, we're going to increase driver awareness. That's ultimately going to increase safety for the workers and for the motorists. And the other thing we're going to focus on today, too, a little bit is work zone speed management and ultimately compliance. We want to have appropriate speed limits by work crews that are exposed to traffic and get the compliance that we desire from the motorists. So we'll talk about all these types of things. Just in the big context of things, we're getting to a point in society here where in our industry where pretty much everything that we have can be connected, whether it's message signs, arrow boards, we've even got workers, digital speed limit signs, AFADs, which are automated flag or assist devices, traffic signals, cameras, sensors, all of this can be connected. So there's no reason right now in today's state of the industry that we can't just, know what's happening in real time as well as have any historical information needed. I wanted to take a minute and just show kind of the big picture of how this might all connect. And on the left of the slide, you're seeing some of these connected devices. Right now, if you look in the top center of this slide, you see the agencies, right? The governmental agencies, and a lot of them have planned events and planned event databases. They're 511 systems and things like that. What they don't really have is historically is that connection with all these field devices that are now providing real-time information. So they're talking about planned closures at night from May to September or something on a particular roadway. they don't really know when exactly they're happening. They may not be on certain nights due to holidays, rain, whatever. And what the goal is now is to take all this connected equipment and marry it with the planned information and create a verified event, something that we can push to the connected vehicles and ultimately just provide very accurate, verified, real-time information to the connected vehicles as they approach. That effort of verifying those things, the agencies vary in their abilities to do that. Some are ahead of others. It often takes several years because it's tied into their automated traffic management systems, their traffic operations centers, and their softwares that they use. So in the meantime, we do also have the ability to go around them to some of these mapping and navigation companies and penetrate into the vehicle or an app, ultimately to provide, alerts and warnings when it's appropriate. So, think Google Maps, Waze, Apple Maps, things like that. So that's just the big picture view of how this stuff fits together and what we're trying to do to penetrate the vehicle. We've got kind of an image here that's several of these devices that we'll spend a little bit of time on each of them, but you can see we've got what I call a start of work zone marker, followed by a digital speed limit sign. None of these are mandatory. One can be used without the others. Connected arrow board when you have a lane closure. Maybe some more digital speed signs just in advance of the workers, and an end marker. All of that can be pushed in real time to be used by the traffic management centers, the mapping and navigation companies, and so forth. So we'll spend a little bit more time talking about that. I like to focus on what I call the low-hanging fruit of that grouping, and that's arrow boards. If you ask any agency if they want to know where all their active lane closures are at any given time, as well as convey that information to the public, the answer is unequivocally yes. And not only that, not only can we take arrow boards and connect them to the cloud and convey this information upstream, but we can even retrofit all the old existing equipment. One of the other nice things is that there's nothing new for the people in the field to do to accomplish this. So this is really, you're seeing a lot of agencies jump on board. ATSSA had put out a brochure. You're seeing pieces of it here. They put that out over a year ago. The intent there was to allow all of you to help, promote that to politicians, upper management within the DOTs. And Iowa's been doing it for probably pushing 5 years now, and with no real heartache or anything. And they estimate that their additional cost is just $1.85 a day extra for renting an arrow board that's connected versus not. And that cost comes down with time. So I just wanted to, share that success that they've had. Real quick, speaking of Iowa, this was in 2023. It's just a look on a month-by-month basis of their, statewide view. And they had over 20,000 events and over 300,000 hours of lane closures throughout the state, with 250 different connected arrow boards. On any peak day, there was as many as 129. And thank you for the Iowa DOT for sharing that information. But it just shows you they've been doing this for many years now, and this technology is proven. It's available by many different providers. And it's absolutely something that every agency should have, as soon as possible, in my opinion. The other nice thing is that our friends at Waze, in the start of 2024, they started adding blocked lanes. They used to just do like construction alerts with the hard hat helmet guy. And now they do blocked lanes, and they will actually tell you if the right or left lane's closed. And these connected arrows can convey that information in real time just through their normal use, and tell you that a right lane's blocked. You can see in this view of an in-dash display, right lane blocked, and the distance to that. And that really, helps the motorist prepare and that is also coming in an audible alert, which is very handy. In addition, we're going to talk a little more in a moment about work zone speed limits, but there's different types of speed signs. You have your common speed feedback sign where it just says, what the speed limit is up above on an aluminum sign, but down below there's a digital feedback of what your speed is. And then there's what we call digital speed limit signs. That's where the speed limit up above the regulatory speed limit's being displayed with a digital LED. And then more recently, we've seen these devices combined onto a single platform. And these are really effective devices to deploy just in advance of the active workers, especially when they're exposed to live traffic. Wisconsin, Massachusetts, and many other states are using these very extensively and having very good results as far as increasing that driver awareness that we talked about. So there's a variety of products there that can meet those needs. Just briefly, we talked about the start and end of a work zone. We've got some markers that go at the, where maybe it says road work ahead, you put one there, and at the end of the work zone, you put an end marker, and you can digitally mark the beginning and end of a work zone. And for work zones that move around and change on a daily basis, that's even more important. Interestingly enough, on Waze, I found this on my own, they were starting to mark, the work zone with like orange lines on the outside. I'm not 100% sure that was meant to be speeds versus the actual work zone, but I think it might be the work zone limits that they're conveying. They do have access to that information, but more and more we're seeing this information, come forward into the apps and vehicles. One of the other things is connected workers. Where are the workers within a work zone? Some of these work zones are, very long and extensive. And what we're seeing is that, digital alerts, well, first of all, let's find out where the workers are and alert the drivers, right? And the National Safety Council in our industry also uses the term vulnerable road user, VRU. And that includes the workers on the side of the road, especially that are exposed to traffic and vulnerable to, being interfered with that traffic. If we can get these alerts into vehicles, any of these digital alerts that we've just mentioned, you can see some of the benefits of that. And this came from another provider of digital alerts. But these studies, the University of Minnesota, potential crashes are reduced by 90%, up to 90% with digital alerts. That's huge. Hard braking events are reduced by 80% with digital alerts. That's really important too, because speed differential is almost as important or more important than speed itself. The differential between two vehicles is what causes work zone incursions and rear end crashes. And then NHTSA also said that speeds are often reduced by about 25% just seconds after receiving an in-cab or in-vehicle digital alert. So these are the reasons why we're doing this, connecting it. We got to be careful about alert fatigue and only doing things that are verified and critical as far as information. We don't want to do information overload here. That's very important. The unit that we use to connect workers, at least with our company, is this little module. It's about the size of a cell phone. You can see my cell phone on the right and the unit on the left. It's actually lighter weight, and you charge it during the off shift just like you would your cell phone. It's very rugged. There's no on and off switch. Once a worker gets into a geofence defined work area, they are recognized and populated, and we can do some things with that information, and we'll talk about that in a moment. One of the applications are, where are the workers? If you've ever been through a job where they're milling up the asphalt and repaving, there's several different operations that are spread over maybe a mile or more sometimes. You've got the milling operation, you've got the sweeping operation, then the paving and the rollers, and then the ultimate striping of the road. There's a lot of people out there that are very exposed to traffic. Sometimes this is right next to a live lane. and they'll do they'll do the right lane and then the left lane, or the inside lane and outside lane. And so maybe what we do is have a sign at the beginning and tell them where the first connected crew is in distance from the beginning of that lane closure in that work area. And so we could automatically convey that information with no intervention, just people wearing the connected modules and conveying that on the advanced upstream, message signs. Another thing that we're involved with is creating digital twins. We call it Work Zone Live. It's a companion app for the connected worker and some of the things that we do with that. But it can literally, by putting a very low cost like RFID tag on an aluminum sign or a roll-up sign, we can actually emulate and manipulate a bit with the app if we need to. We can create a digital copy of everything that's out on the work zone as far as signage. So that's, not all of that needs to be represented or warned into a vehicle, but some people might use it for project management, inventory management, other things, compliance with a layout. So there's a lot of different reasons to do that type of thing. But as you can see, not only are we connecting the electronic equipment, we're starting to connect even the more static equipment that's more of a commodity, if you will, and doing that cost effectively. We'll spend a minute now and talk about just connected equipment and some automated solutions that are being worked on, and just share that with you, to just share possibilities. One possibility is to potentially have a connected arrow board just automatically lower the speed limit on a speed limit sign that's in advance of it. So imagine you just go out, you turn on your arrow board just like you normally would, or you put up your right lane closed symbol, and it could potentially automatically pair and control an upstream speed limit sign, which you allow that information to lower the speed limit, and when it blanks, it reverts back to the normal speed, and we can send instant alerts for that. Another application is to use the connected worker when they're there on site. We can lower the speed limit just in advance of them, and we can use some distance parameters to do that. Look a little bit upstream and maybe a mile or two downstream, and change speed limits as people approach those crews. Another one would take a connected worker, and some states, most states, have higher fines, double fines in work zones. You don't know when they're active or when the workers are there. We could, with the connected worker now, automate and turn on flashers, or really tell people when it's active and when workers are on site. So that's another potential application there. I'm going to spend a moment talking about work zone speed policies and techniques. I'm a little bit on my soapbox, but I think you need to have a sound, proven policy that's consistently enforced from the top down through management. And there are ways to do this. I really believe, as a traffic engineer, that you got to have the appropriate speeds when and where they're appropriate. So don't lower the speeds if you don't need to. Don't lower the speeds in the name of safety just for the heck of it. And we'll get into a hair more detail, but with the connected vehicles and everything, we can start conveying this information. The work zone management, the FHWA has a work zone safety whole section on work zone speed management, and credible speed limits combined with timely advanced warnings. They're absolutely essential for improving the mobility through a work zone. I found a really neat document that Nevada DOT put out in 2015 as part of their safety and mobility implementation guide, and they've got a few things that I'd just like to share with you. One, they said, appropriate speeds ultimately equal compliance. Only lower the work zone speed limits when and where it's appropriate. A lower speed limit does not equal increased safety always. And we'll talk about that for a second. You can see the URL there, and you'll get slides afterwards. But when workers are exposed to live traffic, don't assume that the lower speed limit's just automatically going to improve safety. There are a lot of justification factors. There's roadway factors such as limited sight distance, too many signs, just different things that can, factor into your decisions. There's operational factors such as detours, alignment changes, heavy truck traffic, just the unprotected worker right near live traffic. Those are operational things that might cause you to lower a work zone speed limit. Human factors, I want to spend a second here to just read a few of these from this manual from Nevada. Drivers generally do not slow down until there's a perceived reason to do so. Most drivers determine their speed by observing visual cues. Drivers slow down more when there's feedback signs and flashing lights when it's appropriate. Most drivers do not voluntarily reduce their speed more than 10 miles an hour unless there's law enforcement or automated ticketing involved. And then finally, work zone speed limits that are greater than 10 miles an hour, that lower than the normal posted speed, actually can potentially increase crashes due to a wider spread in speed differentials. So, you get somebody who's very obedient, and then you'll get another car that isn't, and the differentials of those speeds really tackle some, create some problems. There's another document by the Smart Work Zone Deployment Initiative, and there's we can get you the URLs on there for that too. But they also say that you need to, use sound policies that are consistently applied. We did a few case studies the last several years relative to this. And we were using connected workers in Utah years ago in 2018. We actually got 80-mile-an-hour roadways down to 70 through a 10-mile section of work zone where they're resurfacing. We got them down to 50 to 55 miles an hour by the workers, and very successful, cohesive, harmonized flow. And so it is possible to achieve. I'm not going to spend time on the results. We can get to those later. Michigan, a year and a half ago, we used automated work zone speed limits. So when the connected workers were downstream, we were lowering the speeds. If you imagine this sign in the upper right, you don't know whether to drive 60 or 45. It's kind of confusing. So we were actually using digital speed limits to tell people that. And we had some learning lessons there and tweaked a few of the parameters, but it's an automated system. We didn't have to worry. I'll give you an example. These next two, this one in Minnesota, the next one in Wisconsin, what we found is we only did the automation of the higher or lower speed limit on a digital twin of the signs that were actually out there. And what we found is that there was a lot of times where workers were not present and those signs had a lower speed limit and there was no real reason. That's where we're losing, the motorist respect and their level of compliance. Just sharing that with you, and we can get into those findings. But back to that Minnesota slide real quick. 40% of the time we had a speed too low for the conditions in that situation. No blame on anybody there. It's just people, they change the signs when they think of it or when they're scheduled to, and it's not always reflecting the conditions that are happening in the field. One other one we did with Washington State DOT, we're doing it for their survey crews, and they're all over the state, and they just use a roll-up sign. And we were putting them, or we're going to put them on the map this year in phase 2 of this pilot to ultimately convey that information and increase driver awareness and make it safer for these crews when they're out there in these random spots. Some possible future possibilities. There are, when you have a lane closure or workers exposed, you could potentially now, with the connected vehicles, create virtual rumble strips in advance of a connected aero board instead of actually putting rumble strips on the road. We just need the auto manufacturers to get on board with something like that and push that as an industry. So it's something to think about. Another application, and this might be getting a little controversial, but is that Virginia and Washington State have both implemented some laws where they do it under certain circumstances, but they're actually limiting the maximum speed limit of a connected vehicle. They are not letting a connected vehicle go over a certain speed using technology. I know that's a little controversial, but you can kind of see where some of this could go ultimately in the name of safety. Whether our society lets that happen or not, to be determined. Lastly, we're considering starting up what I would call a connected work zone alliance. And I'd like that to be the key agency stakeholders and others that are interested. The goal is to talk with a single voice as an industry to the auto manufacturers, the federal government, and others to really promote this connectivity and getting into the vehicle with the appropriate verified information, and really promoting this as an industry, and ultimately for the safety of the workers, and all of these examples that we just showed you. We're running low on time. My name and phone number are here. I think right now we'll probably open it up for some Q&A, and certainly happy to follow up with you afterwards as well if you'd like.
All right. Thank you. We greatly appreciate you sharing that insightful presentation with us today. We have already received several questions, so let's dive right into the Q&A. If you would like to submit a question, simply type it into the Ask a Question box and click Send. All right, let's dive in.
And I believe we're going to provide PDF of this also after the fact, right?
Sure.
I think it was discussed, so hopefully that'll be available for people too, for some of those URLs and such. Go ahead.
Okay. I think they have it now, by the way, the PDF.
Sure.
All right. Question number 1. Do some unions or employers push back, especially on wearing that device on their safety vests?
They do. So we've seen some pushback in Wisconsin. Actually, a year ago, we did a pilot with them, and the contractor wouldn't wear it, so the DOT personnel did. And that same contractor actually came back to us this year and wanted to wear them, and they actually promoted it at their own conferences after the fact because they understood the benefits. If you think about it, most people have a work phone and their personal phone, which doesn't make sense to me, but they do it. And most of these people are being tracked on their work phone anyway. So, we only track them when they're in defined work zone geofences, not outside of that. And the reason we don't have an on-off switch is because humans are humans and they just forget to turn things on and off. So it is a little bit of an issue here and there, but all in all, we're not seeing a ton of resistance on that.
Okay. Next question is there any guidance about where to locate the start marker, e.g. near a particular sign or a certain distance upstream from the taper or at the taper?
That's a great question, and we've actually talked to a lot of DOTs about that. Each DOT kind of makes up their own version of that. It can be anywhere from that first road work ahead sign. Some people might put it as far back as what they think a typical queue might be that builds up in advance of that even. Others will put it up closer to the lane closure itself. So it's really an agency by agency definition. I think ultimately the drivers and the auto industry would like a little more standardization, but we aren't dictating that. We're letting each agency make that best decision for their agency.
Okay. Next question. Are there particular types of construction activities that are more appropriate than others for automated work zone speed management?
For sure. If there's, in fact, I encourage, I've driven through a lot of work zones over the years, and if you can navigate that thing normally at the normal posted speed, and there's no reason to lower that speed, you shouldn't. The reasons are tight geometrics, workers exposed to live traffic within like 15 feet of live traffic. Those are the types of reasons to slow people down. And even then, you take some of these jobs, they're 10, 15, 20 miles long, and the workers are only in a 1 mile section. Don't slow people down through the entire distance. Only slow them down where you need to, and you'll see better compliance. And we proved that with our Utah study, and that was actually a paper presented to TRB. But good question.
All right. Are there issues with the worker wearable devices losing communication with the upstream message signs? Hold on. There's a second part. I'm just slow. I'm sorry. Are they cell signal, Wi-Fi, radio communication?
It's cellular based. They actually talk to the cloud and then the cloud back down to the sign. So there's a cloud server, if you will. So they aren't talking from device to device. It's not like a mesh network on the ground or anything.
Okay. I think that is all the time that we have for questions. I'm looking at the chat. I'm not seeing any other questions. So we must have got to them all.
Good use of the time. I appreciate everybody's taking the time out of their day to
well, for those questions, if there are some that we didn't get an answer to, we'll be getting back to you via email. So that concludes today's webcast. On behalf of Roads and Bridges, I'd like to thank Todd for sharing the great presentation with us. I'd also like to thank ATSSA for sponsoring today's event. And of course, I'd like to thank all of you for joining us. We hope you have a wonderful rest of your day. Stay cool.
Thank you.